Martin and I are recording this module 11 on your own, 11.1, 11.2, and 11.3 video. So Martin, will you please read 11.1?
Student is asked to dissolve 50.0 grams of potassium chromate, an orangey yellow solid, in 250 milliliters of water. He is having a hard time getting all the solid to dissolve, but is not allowed to add any more water. What should he do to try to make sure all 50.0 grams dissolve?
Okay, well, this chapter is called The Chemistry of Solutions, okay? And here on page 362, we see some information that's in bold at the top of the page, okay? Martin, read it to me, please.
For solid solutes, solubility
Don't shake the table.
usually increases with increasing temperature.
Keep
The
going.
solubility of liquid solutes is not increased by temperature. The solubility of gases decreases with increasing temperature.
Okay, so it tells us something about solubility and temperature. Solubility means the ability of a solute to dissolve in a liquid, okay, or a solution. So in this case, we have a solid solute, right? Potassium chromate, we're told, is a solid. So that means that we can increase the solubility of this solute by increasing the temperature of the solution. So in other words, we can heat the water. If we make it warmer, then the solubility of the potassium chromate will increase. So that is the way that the student can increase the solubility, by increasing the temperature. Does that make sense to you?
Uh-huh.
Do you have any questions about that?
No.
Okay. Does that answer the question fully?
It does.
How about 11.2?
A chemistry lab is storing several bottles of a solution made by dissolving methane gas in octane, a nonpolar liquid. The laboratory chemist notices that every once in a while the lids from the bottles pop off. She reasons that the lids are popping off because the gas that is dissolved in the liquid is escaping from solution. What can she do to stop the lids from popping off?
Okay, so in the bold part that Martin read, no, she could secure them tighter, sure, or she can do something else. In the bold part that you read on the top of page 362, what did it say about solubility and temperature when you're dealing with the gas?
The solubility of gases decreases with increasing temperature.
So how can she increase the solubility?
By cooling them.
By decreasing the temperature. So she can refrigerate her bottles. If she refrigerates her bottles or makes them colder, then she will increase the solubility, the ability of the gas to stay in solution. Okay?
A student is doing an experiment that involves dissolving a gas in water. He notices that even though the temperature in the lab is exactly the same every day of the year, there are some days in which more gas can dissolve in water as compared to other days. What, most likely, is changing from day to day in order to produce this effect?
This is also on page 362.
Pressure.
Okay, so we talked here about the temperature and solubility, but there's also deal with pressure and solubility. So if we increase the pressure, we increase the solubility of the gases. Okay, it will not affect liquids and solids, but they're talking about gases. So the atmospheric pressure in the lab is different from day to day. They can maintain a temperature, but the atmospheric pressure is different. It's harder to maintain atmospheric pressure in the lab. They can do that, but generally that's not going to happen. And so what's happening there is that the atmospheric pressure is different. Okay, any questions on those?
Nope.
All right, thanks for joining us.